begin with the breaking news. Those images coming in from the Gulf of Mexico tonight, a deadly blast.
On the morning of June 19, 2025, along the coast of Progreso, Yucatan, something extraordinary began beneath the surface of the Gulf of Mexico. Massive dredging machines moved slowly through the warm Caribbean waters, their enormous suction pipes descending toward the seabed. From a distance, the scene looked almost peaceful. But beneath the surface, hundreds of millions of cubic feet of sand and sediment were about to be removed. Mexico was not simply building a port. It was attempting to reshape the coastline itself. But before we go any further, please subscribe to the channel and help us reach our goal of 5,000 subscribers. Because what happened next beneath the Gulf of Mexico was far more than an ordinary construction project. It was the beginning of a transformation that could change Yucatan's future, reshape Mexico's trade routes, and potentially alter one of the most important coastlines in the region. And the deeper the dredgers went, the bigger the mystery became. Why was Mexico removing such an enormous amount of material from the seafloor? What was the real purpose behind this unprecedented operation? And could the economic promise of a new deep-water gateway come at an environmental cost that no one could easily reverse? The scale of the operation immediately raised a question that few people were asking. Why would Mexico undertake such an enormous and expensive transformation of the Gulf seabed? Officially, the answer was straightforward. Progreso needed deeper and wider navigation channels so that larger cargo ships could finally reach Yucatan. But as the machines began tearing into the seafloor, a much bigger story emerged. This was about trade, geography, industry, and Mexico's rapidly changing position in the global economy. And beneath all of it was a question that could determine the future of the entire peninsula. Could Yucatan finally become the maritime powerhouse its geography seemed to promise? To understand why this discovery beneath the Gulf matters so much, we have to travel millions of years into the past, to a time when the world looked nothing like it does today. Around 66 million years ago, a massive asteroid struck the region that is now northern Yucatan. The impact created the Chicxulub crater, one of the largest impact structures ever discovered on Earth. The collision triggered environmental changes so severe that the age of the dinosaurs came to an end. In the aftermath, mammals began expanding into ecological niches that had previously been dominated by reptiles. Eventually, much later, humans would arrive on this same landscape. That ancient impact shaped far more than the history of life. It also helped create the geological foundation of modern Yucatan. Beneath the peninsula lies an enormous formation of limestone, porous rock that allows rainwater to disappear underground and carve out vast networks of caves and underground rivers. Over thousands of years, some of these underground systems collapsed, creating the famous cenotes scattered across the peninsula. To the ancient Maya, these deep pools were not merely geological formations. Many were sacred places associated with the underworld and the gods. To modern scientists, they are windows into the region's climate, geology, and human history. Above those hidden underground worlds, another landscape emerged. Dense tropical forests spread across the peninsula, creating habitats for jaguars, monkeys, reptiles, and countless species of birds. Along the coast, brilliant white beaches meet turquoise water, attracting millions of visitors every year. From almost every angle, Yucatan appears to be a paradise. Yet the same geology that created its extraordinary beauty also created one of its greatest economic weaknesses. The coastline is remarkably shallow. In many areas, the seafloor remains relatively flat for long distances before reaching the depths required by large modern cargo ships. For centuries, this made maritime transportation difficult. Ships could not simply sail toward the shore and unload their cargo at a conventional deep-water harbor. Instead, goods had to be transferred between vessels, increasing costs and slowing trade. Geography had effectively placed a ceiling on Yucatan's economic potential. That became increasingly frustrating, because Yucatan occupies an extraordinarily strategic position. Look at the map, and the contradiction becomes obvious. The peninsula sits between the Gulf of Mexico and the Caribbean, relatively close to the United States, Central America, and major transatlantic routes. In theory, it should be one of the great crossroads of the Western Hemisphere. But while ports such as Veracruz, Manzanillo, and Lázaro Cárdenas developed into major commercial gateways, Yucatan remained comparatively disconnected from the largest currents of maritime trade. For decades, economists and planners viewed the region as a sleeping giant. It had tourism, agriculture, natural resources, cultural heritage, and a location that other regions could only dream of. What it lacked was the infrastructure necessary to convert those advantages into global economic power. The peninsula was rich in potential but trapped by its own coastline. Then the world around Mexico began changing. By 2024, Mexico had become the United States' largest trading partner, reflecting a dramatic transformation in North American supply chains. Companies that once depended heavily on manufacturing networks in Asia increasingly began looking toward Mexico. The strategy became known as near-shoring, moving production closer to the final consumer in the United States and Canada. Factories expanded, logistics networks became more important, and the movement of goods across North America accelerated. The numbers behind this transformation were enormous. Automotive components, finished vehicles, electronics, agricultural products, petroleum, machinery, and consumer goods were moving constantly between Mexico and the United States. Manufacturing centers such as Monterrey, Guadalajara, and Mexico City became increasingly integrated into a continental production system. But there was a problem. Manufacturing something is only half the battle. Getting it to customers is the other half. And in the modern global economy, the most important arteries of long-distance trade are still the world's oceans. Giant container ships carry enormous quantities of goods across international waters. Modern post-Panamax and new Panamax vessels are vastly larger than the ships that dominated global trade during the middle of the 20th century. Some can carry thousands upon thousands of containers on a single voyage. But these enormous ships require enormous infrastructure. They need deep channels, wide turning areas, modern cranes, large storage yards, and highly efficient connections to roads and railways. A port can have a perfect geographic location, but if its channel is too shallow, that location becomes almost meaningless. And this is where Yucatan's greatest contradiction appears. The peninsula was sitting beside one of the world's most important maritime regions, yet its principal port, Progreso, could not comfortably serve the largest ships, transforming global commerce. Instead, cargo frequently had to travel through other Mexican ports before continuing toward Yucatan. That added time, increased costs, and made local producers less competitive. For a global shipping company operating on extremely tight schedules and thin margins, even small inefficiencies can become major problems. A shipment delayed by hours can disrupt an entire supply chain. A container that must travel hundreds of extra miles by truck or rail creates additional fuel, labor, and handling costs. Eventually, businesses begin looking for alternatives. That meant Yucatan was losing opportunities simply because its ships could not reach the coast efficiently. But what had once been considered a weakness was suddenly beginning to look like an opportunity. As global trade expanded and companies searched for new logistics routes, the absence of a major deep-water gateway in Yucatan became impossible to ignore. If Mexico could transform Progreso into a modern deep-water port, the peninsula could suddenly move from the edge of the shipping network toward its center. And nowhere was that ambition more visible than at Progreso. From the air, Progreso's famous pier looks almost surreal. It stretches deep into the Gulf of Mexico like a giant concrete road disappearing toward the horizon. The structure became one of the defining symbols of Yucatan's struggle against its geography. Because the coastal waters were so shallow, engineers had to build outward into the Gulf to reach deeper water. The origins of this strategy go back to the early 20th century. By the late 1930s, engineers had embraced the idea of extending the pier far enough into the Gulf to allow larger ships to approach. Over subsequent decades, the structure was expanded and upgraded, particularly during the 1980s, as trade and tourism increased. For a time, the strategy worked. Progreso became a maritime lifeline for the state. Agricultural products moved through the port, imported goods arrived, and cruise ships brought tourists from around the world. But global shipping kept changing. The ships became larger, containers became more important, port technology evolved. And suddenly, the very infrastructure that once represented Yucatan's modernization began to look outdated. The channel at Progreso remained relatively shallow and narrow compared with the requirements of today's largest vessels. Ships approaching the port had to carefully consider their draft and maneuvering requirements. Some of the world's largest container ships simply could not use the port efficiently. The result was a strange contradiction. Yucatan possessed a pier that stretched for miles into the Gulf, yet the world's biggest ships still could not fully take advantage of it. The structure had become a symbol of ambition without complete access. For locals, that contradiction carried an emotional weight. To some, Progreso demonstrated what human engineering could accomplish when nature presented an obstacle. To others, it was a warning. Building a spectacular structure was not enough. Infrastructure had to evolve with the world around it. Now, in 2025, Mexico was finally confronting that problem directly. Instead of extending the pier farther into the Gulf, engineers were going after the obstacle itself, the seabed. The solution was extraordinary in its simplicity and staggering in its scale. If the water was too shallow, make it deeper. If the channel was too narrow, make it wider. If geography had restricted Yucatan for generations, reshape the geography. That decision transformed Progreso from a conventional port upgrade into one of Mexico's most ambitious maritime engineering projects. On June 19, 2025, dredging operations officially began. Massive dredgers entered the waters around Progreso, preparing to remove an enormous quantity of sediment from the Gulf floor. The target was hundreds of millions of cubic feet of material, enough to fundamentally alter the underwater approach to the port. The machines working offshore were unlike anything an ordinary observer would encounter. Trailing suction hopper dredgers operated like enormous floating vacuum cleaners, lowering massive pipes toward the seabed and sucking up sand, silt, and sediment. Other specialized dredgers could cut through harder layers of compacted material before pumping the excavated sediment toward designated areas. The objective was not simply to clean the channel, it was to create a new maritime gateway. The plan called for the navigation channel to be deepened and widened, allowing larger vessels to approach Progreso with greater safety and efficiency. On a map, a few feet of additional depth may not look dramatic, but in the world of container shipping, those few feet can determine whether a vessel can enter a port or must find another destination. Suddenly, the old pier to nowhere had a possible future. And that is where the real discovery begins. Because this project is not merely about dredging sand from the Gulf, it is about whether Mexico can use Yucatan's strategic location to create an entirely new corridor connecting maritime shipping with manufacturing, rail transportation, tourism, and international trade. If the transformation succeeds, Progreso could become more than a port. It could become the front door to a new economic era for southern Mexico. But every revolution has a cost. And beneath the machines, beneath the ships, beneath the millions of cubic feet of sediment being removed from the seabed, another story is unfolding. The Gulf of Mexico is not an empty space. It is a living ecosystem. And the deeper Mexico digs, the more difficult the question becomes. How much can the Gulf endure before the price of progress becomes impossible to ignore? By the time the first dredgers moved into position off Progreso on June 19, 2025, the idea of transforming Yucatan's maritime future had already been discussed for years. But discussion was no longer enough. The shallow waters that had restricted the peninsula for generations were now being treated as an obstacle that could finally be removed. Mexican authorities had reached a simple but extraordinary conclusion. If ships could not reach Yucatan because the seabed was too shallow, then the seabed itself would have to change. That decision gave birth to a dredging operation on a scale rarely attempted along this part of the Gulf of Mexico. Engineers planned to remove roughly 353 million cubic feet of sediment from the seabed, an amount so enormous that it is difficult to visualize. Imagine thousands of Olympic-sized swimming pools filled with sand, silt, and gravel, and then imagine all of that material being lifted from beneath the Gulf. This was not ordinary port maintenance. It was an attempt to physically rewrite the underwater geography surrounding Progreso. The engineering objectives were precise. The port's fairway was planned to become deeper, increasing from roughly 40 feet to 44 feet, while the navigation channel would expand from about 492 feet to 590 feet in width. 4 feet may sound insignificant when viewed from land, but at sea, those few feet can determine whether a massive container vessel can safely enter a harbor or must turn away. Every additional inch of navigable depth can translate into greater cargo capacity, safer operations, and access to a new generation of ships. To carry out such an enormous task, Mexico turned to Mexicana Dragados, associated with the Belgian-based Jan de Nul Group, one of the world's major dredging and marine engineering companies. Jan de Nul had experience working on some of the most difficult marine construction projects on Earth, from major canal operations to massive land reclamation projects. Their involvement gave the Progreso project something it desperately needed: the technical experience required to transform an ambitious plan into a functioning reality. Then, on June 19, 2025, the transformation moved from paper to water. The Gulf around Progreso became a vast industrial construction zone. Huge trailing suction hopper dredgers began moving across the sea, their enormous hulls functioning almost like floating factories. Their suction pipes descended toward the seabed, pulling up layers of sand, silt, and fine gravel. Inside the vessels, the material was collected, transported, and eventually deposited at designated locations where it could contribute to reclamation and the creation of new land platforms for future port infrastructure. But not every section of the seabed could be removed so easily. In harder areas, cutter suction dredgers took over. These machines were essentially giant underwater excavation systems, equipped with rotating cutter heads designed to break apart compacted layers of clay and sediment before the material could be pumped away. Watching them work created an almost surreal impression. It was as if a city was being constructed in reverse, with land first disappearing beneath the waves before being transformed into the foundation of something that had never existed there before. Yet the greatest challenge was not simply the amount of material being removed. Progreso could not stop functioning while the transformation took place. The port remained an essential maritime connection for Yucatan, handling cargo vessels and cruise ships even as construction continued around them. That meant dredging operations had to be carefully coordinated with commercial traffic. Ships still needed to arrive, maneuver, unload, and depart, while enormous dredging machines worked nearby. Every movement, therefore, became part of a complicated logistical ballet. A dredger could not simply move wherever it wanted. A cargo vessel approaching the port could not always wait indefinitely. Construction schedules had to be synchronized with tides, shipping movements, safety requirements, and environmental restrictions. The project was therefore not just a battle against the seabed, it was a battle against time, traffic, weather, and the unpredictable nature of the Gulf itself. But behind all the machinery was a much larger ambition. For decades, Yucatan's shallow coastal waters had effectively dictated what the peninsula could become. Geography had shaped its economy, limiting the size of ships that could reach its shores and forcing businesses to depend on distant ports. Now, Mexico was attempting to reverse that relationship. Instead of allowing geography to determine the future, engineers were attempting to modify the geography. That is what made the Progreso project so significant. The dredging was not simply about creating a deeper channel. It represented the possibility of giving Yucatan something it had been missing for generations: direct access to the modern global shipping network. If successful, the peninsula could finally connect its agricultural producers, manufacturers, exporters, and consumers directly to international maritime routes. But there was a deadline hanging over the entire operation. The project was expected to progress toward completion in 2026, meaning that engineers had only a limited window to accomplish an enormous amount of work. Every delay could have consequences. Equipment failures, weather disruptions, unexpected seabed conditions, budget pressures, or environmental restrictions could slow the operation. And there was another problem that no engineer could simply solve with a larger machine: skepticism. For years, Yucatan had been described as a region full of unrealized potential. Many ambitious plans had promised transformation before. The question was whether this one would actually deliver it. By the middle of the project, however, signs of physical transformation were becoming impossible to ignore. New platforms were beginning to emerge from the water. Construction equipment appeared along the horizon. Cranes stood ready for the next phase, while beneath the surface, the navigation channel was gradually taking shape. Progreso was beginning to look less like a forgotten pier and more like the centerpiece of a new maritime system. And if that transformation succeeded, the effects would not stop at the shoreline. The real shock would come inland. Because the moment deeper channels allow larger ships to reach Yucatan, the entire economic equation begins to change. The dredging project could reduce one of the region's biggest logistical bottlenecks, allowing goods to move more directly between Yucatan and international markets. For exporters, that could mean faster shipping, lower transportation costs, and fewer delays. For decades, producers across the peninsula had faced a difficult reality. Citrus farmers, honey cooperatives, furniture manufacturers, textile producers, and other businesses could produce competitive goods, but getting those products to international buyers was another matter. Without direct deep-water access, cargo often had to travel through distant ports, adding additional handling, transportation costs, and uncertainty. A modernized Progreso could change that equation almost overnight. Imagine a shipment of tropical fruit leaving a farm in Yucatan and reaching a deep-water terminal without having to travel hundreds of additional miles to another Mexican port. Imagine manufactured products being loaded directly onto large container vessels and sent toward Europe, the United States, or the Caribbean. Every unnecessary transfer eliminated from that journey would save time and money. For importers, the benefits could be just as significant. Machinery, electronics, fuel, industrial components, and consumer products could enter the peninsula through a more efficient maritime gateway. Instead of depending heavily on distant ports, businesses could have a major commercial entry point much closer to their operations. And that is when the story begins to move beyond shipping. Foreign investors began looking at the region differently. A modern deep-water port can attract far more than cargo ships. It can attract factories, warehouses, distribution centers, logistics companies, processing facilities, and entire industrial ecosystems. Businesses tend to follow infrastructure, and infrastructure tends to follow opportunity. The land surrounding Progreso and Merida could therefore become increasingly valuable as companies search for locations close to transportation networks. A factory located near a deep-water port can reduce shipping distances. A distribution center can move products faster. A logistics company can coordinate imports and exports more efficiently. One project can therefore create a chain reaction. A new port creates demand for warehouses. Warehouses create demand for workers. Workers create demand for housing, restaurants, transportation, schools, and services. Businesses generate tax revenue, and governments can potentially reinvest that revenue into roads, hospitals, utilities, and public infrastructure. This is how an infrastructure project can transform an economy without every person ever stepping onto a ship. But the economic promise also reveals the scale of the gamble. Because every cubic foot of sediment removed from the Gulf raises another question. What happens to everything living around it? The Gulf of Mexico is not an empty construction site. Beneath the surface is a complex ecosystem shaped over thousands, and in some cases, millions of years. Fish, seagrasses, algae, coral communities, turtles, microorganisms, and countless other organisms depend on the delicate balance of water quality, currents, temperature, and sediment. Dredging inevitably disturbs that balance. When a dredger cuts into the seabed, enormous quantities of sediment can become suspended in the water. What appears from above as nothing more than a cloud of brownish water can become a serious problem for marine organisms. Fine particles can reduce water clarity, interfere with feeding, settle over sensitive habitats, and alter conditions in areas where fish and other species reproduce. For marine ecosystems, the danger is not necessarily the disappearance of everything overnight. The greater concern is disruption. A spawning ground disturbed at the wrong moment can affect an entire generation of fish. Sediment settling over sensitive seagrass or algae beds can reduce their ability to function as nurseries for marine life. Changes in currents can alter where sediment eventually accumulates, potentially creating effects that continue long after the dredging machines have left. That is why the environmental question surrounding Progreso is so important. The project cannot simply be judged by how much sediment is removed or how quickly the channel becomes deeper. Its true success will also depend on what happens to the ecosystem after the machines disappear. To reduce those risks, environmental safeguards become critical. Sediment control barriers can be deployed to limit the spread of suspended particles. Monitoring systems can track water conditions, while dredging schedules can be adjusted around sensitive ecological periods. Restrictions may also be necessary during important fish spawning periods or sea turtle nesting seasons along Yucatan's beaches. On land, the situation becomes equally complicated.